Hey everyone, welcome to today's Pre-Lab Explainer. So before you grab a seat at your workstations to knock out Lab Program 1, we really need to make sure we're all speaking the exact same technical language. Today we're going to logically break down the core terminologies that make the internet actually function. Because as engineers, you can't just casually use these tools. You need to fundamentally understand the underlying theory and the specific purpose of each one. Here's our quick game plan for today. Section 1, the lab objective. Section 2, core infrastructure basics. 3, communication and file protocols. 4, navigating the web. And we'll wrap it all up with Section 5, the lab conclusion and result. Let's get into it.
All right, kicking things off with Section 1, the lab objective, setting the goal for today's practical.
So this is our direct aim, literally straight out of your lab manual. Our goal today is to study and understand 6 foundational pillars of connectivity: ISP, email, Telnet, FTP, web browsers, and search engines. That specific checklist right there, that's our entire focus for this session. But hey, before we dive into those 6 specific tools, we've got to establish our baseline theory, right? The internet itself is, simply put, a massive global network of interconnected computers. It facilitates communication and information sharing. Think of it as this giant physical and logical web of routing equipment and servers. Everything we're exploring today is really just about how we efficiently harness that vast global resource.
Moving right along to Section 2, Core Infrastructure Basics, the foundation of connectivity. Okay, so our first major term is ISP, or Internet Service Provider. By definition, this is an organization that provides internet access to users. I mean, your lab workstation might be an absolute multi-thousand-dollar powerhouse, but without an ISP acting as, the ultimate bouncer to the club of the internet, your connectivity to that global web is literally zero.
Their sole purpose is just making that connection happen. They are the bridge. And you've definitely used this bridge before. We're talking about real-world providers like Airtel, Jio, or BSNL. When your lab machine connects today, it is routing straight through one of these guys.
Up next, Section 3, Communication and File Protocols. Basically, how data actually moves.
The absolute most ubiquitous service here is email, right? Electronic mail. The theory defines it as a service used to send and receive digital messages over the internet. It's all about electronic communication. You're using this protocol literally every single day, relying on massive platforms like Gmail, Outlook, or Yahoo Mail to handle all that heavy routing and storage.
Now let's get into some real engineering-specific territory. Telnet. This is a network protocol used for remote login and command execution on another machine. Look, as engineers, you are not always going to have the luxury of physical access to the servers you manage. Telnet lets you log in remotely and run commands exactly as if you were sitting right there at the server rack. It's a total lifesaver. But what if you need to do more than just type commands? What if you need to physically move huge data sets? That's where you'll rely on FTP, the File Transfer Protocol. This protocol is explicitly designed to transfer files between a client and a server over a network, so file uploading and downloading. When you need a robust way to push your code to a server or pull down a massive database backup, you'll open up client software like FileZilla or WinSCP.
I love this table because it perfectly maps out your toolkit. Need to send a quick digital memo? That's email. Need to configure a remote server via the command line? Telnet's your tool. Need to push a massive application package? That's FTP. Knowing exactly which protocol to reach for is a fundamental engineering skill you absolutely need to master.
All right, Section 4, Navigating the Web. Looking at the user interfaces.
Here is an absolutely crucial architectural point. The internet and the web? Not the exact same thing. The web is accessed through a web browser, which is the software used to access and display web pages. Its primary purpose is to take the raw code being sent over the network and render it into those nice, graphical interfaces you actually interact with.
Obviously, you're super familiar with tools like Chrome, Firefox, or Edge, but seriously, don't underestimate them. These are incredibly complex pieces of software working tirelessly in the background to translate network data into a seamless user experience.
But hey, a browser isn't much use if you don't know where to look, right? Once you're inside the browser, you need a search engine. Our manual defines this as a massive software system that searches information on the World Wide Web. Its dedicated job is information retrieval. There are literally billions of web pages out there. A search engine constantly crawls, indexes, and ranks them all so you can actually find what you need instantly.
For effective, instantaneous info retrieval, we use engines like Google, Bing, or DuckDuckGo. And catch the distinction here. The web browser is the local software running on your own computer, while the search engine is a remote service you access through that browser to sort through the internet's vast data.
And finally, Section 5, Lab Conclusion and Result. Wrapping up our practical.
Every solid lab experiment needs a verified result. Having gone through the theory for this explainer, we can state our observation and result clearly. The various internet terminologies such as ISP, email, telnet, FTP, web browsers, and search engines were studied and explored successfully. Boom! We've officially met the core aim of our practical session today.
But much more importantly for your actual careers as engineers, their functionalities, applications, and their critical importance in internet communication and information retrieval were completely understood. You don't just know what they are anymore, you understand exactly why they exist and how they differ from one another.
So as you gear up to head into the physical lab and put this theory into practice, I want you to think about this. Looking back at everything we covered, from the remote command execution of Telnet to the heavy data lifting of FTP, which of these foundational tools is going to be the absolute most vital for your specific future engineering path? Just something to chew on. All right, thanks for hanging out for this pre-lab explainer, and good luck knocking out Lab Program 1.